All right, well, good morning or afternoon, depending upon where you're at. Welcome to this section. Today we're going to talk about percent and interest. So let's start with just a definition of what a percent is. So we say that n% of a number is defined as n over 100, where n is any non-negative number. Okay, meaning we don't allow for negative percents. That doesn't really have any meaning for us. The word percent is actually from the Latin origin. It comes from the phrase percentum, which means per hundred, which explains why we usually keep track of these things in terms of 100. So let's take a look at a couple of quick illustrations of this. So let me write a couple of numbers down. So let's say 0.03. Let's do 0.3 repeating, so 0.33333. 1.2, and then let's do some fractions here. So 3/5, we'll do that one, and then we'll do 2 1/7. Okay. So what our goal is in each case is to write a fraction over 100. So 0.03 literally represents 3/100ths. And so that would translate into 3% total. So another shorter sense as we move the decimal over 2 places. 0.3 repeating would mean 33.3, again, with that repeating over 100. And so that would translate to 33.3% with the repeat symbol. 1.2 would translate to 120 over 100. And so that would be 120%. And then we get to the fractions. So in the fraction case, again, I want to try to make it to have a common denominator of 100. So what can I multiply 3/5 by so it says over 100? And that would be 20 over 20. So that would translate to 6 over 100, which then means 60% for that fraction there. And then the last one, 2 1/7. I want to, let's see, so we're going to first make this an improper. And then I want to figure out how to make that say over 100. So that's going to be, 2 times 7, 14, 15 over 7. And I want to make that say over 100. So I'm going to multiply that by 100 over 100, which is going to become 1500 over 7 and divided by 100 there. And then I just want to figure out how many times does 7 go into 1500. And that works out to be about 214. Well, let me show this. I'm trying to do way too much in my head here. Okay. So 7 goes into 1500. Okay, so 7 goes into 15 twice with 1 left over. Drop down the 0. It goes in there once with 3 left over. And it goes in there 4 times with 2 left over. Sorry, 2. So 214 and 2/7. So in other words, unless I start coming up with a decimal approximation for 2/7, then that's about as close as I can get, or that's actually an exact answer. So this would translate to 214 and 2/7%. So it is okay on occasion to mix a fraction with a whole number and actually have a fractional percent. That is an acceptable interpretation. Okay, so now that we've had a little bit of practice taking a number and making it into a percent, let's actually take a look at looking at application problems and how that works. Now, when we do application problems, there's usually one of 3 goals, generally speaking, that involves some sort of percent problem. So our first goal, or one of our goals, could be finding the percent of a number. Okay. Our second goal could be finding what percent one number is of another. So finding what percent one number is of another. And the third thing that we typically could be asked to do is finding a number when the percent of that number is known. So we can find a number when we know the percent. And before we get too excited about looking at applications, let's kind of remind ourselves of a couple of things. Let's take this idea of a fraction, so 2/3 of 70 versus 40% of 70. Okay, now in the 2/3 of 70, we actually translate that to mean 2/3 times 70. And then we can just multiply that out. So let's see, 2/3 of 70 would be 140 over 3. And then we just have to figure out how many times does 3 go into 140. So that goes in there 4 times with 2 left over. That goes in there 6 times with 2 left over. So we can kind of see that we're just going to get this repeating number. Okay, so that would translate into 46.6 repeating percent. 40% of 70, again, is the same sort of multiply idea. So 40% will translate into 40 over 100 times 70. And let's see, so we can take out a 0, and that'll give us, actually I don't want to do that, do I? I want to keep this over 100, because I want to keep the meaning of the word percent. Okay, so then I just want to multiply across, so 2,800 over 100 would translate into, that's right, divide that out, I get 28. Okay, so we do get 28% on that one. Now, graphically then, what that sort of gives us a sense of meaning, if I use something called a percent bar, sorry, hold on. Okay, so if I use a percent bar to model this, especially that, let's look at that 40% of 70. Okay, so we're going to say that there's 70, kind of label a couple of key ideas because we know 35 is about halfway. So in terms of percent, we're saying that's all of 70. And if I want less than half, so I'm trying to figure out what number would that be. So what number less than 35 would actually translate into 40%. And so it kind of makes sense that 28 is less than 35, so that's kind of a reasonable estimate. Okay, so our first application problem, house that sells for $92,000 requires a 20% down payment. What is the amount of the down payment? Okay, so in terms of our percent bar, okay, so we'll start with 0 and 0. We're saying the house costs $92,000. Here's 100%. I would like to know where 20% is. So what's this number that represents that amount? Okay. So I'm going to set up a proportion of type. So I'm going to go x over 92,000 equals 20 over 100. And since we're using our proportional reasoning logic, I can cross multiply that. So that's 100x equals 20 times 92,000. And so I want to divide that by 100. Okay, and I think the numbers are big enough that a calculator would make sense in this case. So I'm going to pull out a little calculator. And I want 92,000. Oops. My calculator does not like me at this moment. Okay, let me pull up another calculator. Okay, and so the numbers are of the size that I think a calculator would be fine. So 92,000 times, make sure I get my calculator in here, times 20. And then I want to divide that by 100. Okay, so I expect a down payment to be $18,400. And in the context of the picture, that makes sense. I mean, 18,000 clearly is a small enough number that I would expect it to be about near 20%. All right, if Alberto has 45 correct answers on an 80 question test, what percent of his answers are correct? Okay, so let me draw a fraction bar here. There's 0, there's 100. All right, so there's 80 questions on the test. Let's see, I know where 40 is. 40 is around the 50% mark. But where's 45? So there's that number right there. That's the mystery number that I want. So I want to know what percent that would represent. So setting up my proportion, 45 over 80 equals x over 100. And so cross multiply and divide, I get 45 times 100 divided by 80 will tell me what the percent is. Okay, so let me pull up a calculator. And I want 45 times 100. And I want to divide that by 80. And I get 56.25. So that would translate to be 56.25%. And that makes sense because it's a little bit more than 50%. So that definitely is a reasonable answer.